So we already have talked a lot of theory in the last few classes, and it's now time to discuss some examples. So let's begin with this example. In rotational dynamics, we have a wedge and this wedge has a pulley, and there's a mass here and there's a mass here. Let's say there's no friction in the system. The pulley is a disc, and mass of this guy is 10 kilograms. Mass of this guy is again 10 kilograms. This angle here is 45 degrees, and the mass of the disc, now disc has mass. We have already solved this problem, but in that case we assume that there was no mass to the disc, and the mass of the disc is, let's say again, 10 kilograms. This will simplify things. And what is happening, this rope is not slipping on the pulley. It's not slipping. This is a pulley, and the rope is not slipping on the pulley. Okay, how to solve this problem? Again, whenever we have a mechanics problem, we always start by making free body diagrams. So let's make free body diagram of the 10 kilogram mass. We already have done this, but let's do it. Now we know there are three forces. There are three forces acting. First, there's a normal reaction acting on the mass. Let's call it N. There's a force of gravity acting, so let's call this 10G. For the sake of simplicity, let's take G to be 10, but probably let's take G to be 10. Oh, I should have mentioned the radius of pulley is 0.1 meters. So we need all this information. Okay, now here's the tension T, and we have this mass, which is 10 kilogram again, but it's hanging like this. It is being acted downwards by 10G. There's a tension acting upward. And we also have to make free body diagram for the pulley, because pulley now has a mass. It is being acted by a mass. It's moving like a disc. There's a torque acting on the pulley. So there's a T here and T here. Okay, and now we have to write Newton's equation. But before that, you might have noticed that I have made a mistake. There's something which is wrong. Can you guess what that is? First of all, we already have assumed that this whole system is moving down with an acceleration a. So you can say this is a, this is a, and this is also a. But this looks alright. This looks alright. How about this? Can this guy have a rotational acceleration a? Well, you see, if it has a rotational acceleration a, it will have angular acceleration a over r. And there is angular acceleration only when there is a net torque present. We already remember that sum of torque equals I alpha. But looks like this guy, this tension here, don't confuse between tau and T. This is torque and this is tension. This guy is producing a torque in the anti-clockwise direction, and this guy is producing a torque in the clockwise direction. So the net torque on this system is 0. So the net torque is 0, then it cannot have any acceleration alpha or a translation acceleration a. So there we have made some mistake. So how to fix that? Well, we wrongly assumed tension to be same. It should be T1 and T2. They should have different. The tension should be different. There is one more thing which we did not discuss, was the direction of torque. How would you define the direction of torque? if you have a body and there's a torque present like this, a force present like this, then this force we know is going to rotate the object anti-clockwise. And to know direction of torque, we have to use, we know how torque is given. We know torque is given as F perpendicular times the radius r, whereby F perpendicular we say is this component that is making the object move in circle. Sorry for the bad diagram here. This is the force. Okay, so what is the direction of the torque? Let's make it clear. Looks like I have to undo everything. So this is the force, then this is F perpendicular, torque is F perpendicular times radius. Torque is a vector, so direction is given by right hand rule, which means, as we can see, this guy here will make the object go clockwise, anti-clockwise or counterclockwise. So what we do is curl our finger along the direction of motion or along the direction of rotation, and the thumb tells us the direction of torque. So here, as you curl the fingers around the direction of motion, you will see the thumb is pointing upward, which means out of screen. Now whether it's negative or positive depends how you define the axis system. If you define Z to be up in the plane, then it's positive, and if you define Z down in the plane, then it's negative. So that depends on your definition of x-axis. But let's solve this. What's happening here? Okay, let's write Newton's equation for this guy. We already know that this force is going to be 10 cos 45. You can figure out how. We already have done this. And let's write Newton's equations for this one and this one. For this one we get T1 minus 10 cos 45 degrees equals 10 A. For this guy it's 10G minus T2 equals, we should have mentioned the direction. Let's say this is the x-axis, this is the y-axis, and let's say up is the y-axis for this guy. So this should be minus 10G plus T2 according to the direction of y-axis equals minus 10A. So this is the first and this is the second. The third equation is based on this, which gives us that now T2 is T1. Let's define Z to be coming out of the plane. So for this guy, let's define this to be X. Let's define this to be Y, and then Z will be coming out of the plane. So T1 is rotating the disc such that thumb is coming out of the plane. So T1R is the torque which is in the direction of the z-axis, so it's positive, minus T2R equals I alpha. Now I for the disc is, we know, mr square over 2, so it's going to be 10.1 square over 2. And alpha is nothing but A over R, so it's going to be A divided by 0.1. So that is nothing but T1R minus T2R. As a matter of fact, we can take R also outside, so we get T1 minus T2 equals 5A, right? This is the third equation. And you see, these three are very simple equations. They can be very easily solved. First of all, you can substitute T1. Okay, let's do that. So first becomes, number one becomes, from here you can write T1 equals 5A plus T2. So let's substitute that here, and we get 5A plus T2 minus 10 cos 45 degrees equals 10a, and the second equation, which is this one, becomes minus 10g plus t2 equals minus 10a. Now both these equations are in terms of t2 and a, and you can solve them to find the value of t2 and a. Once you have that, you can also find the value of t1 using one of these equations. So that's how we solve this problem.